from IGCSE past paper questions. This is the first question we're going to start to solve. The question 1, figure 4.1 represents part of the hydraulic braking system of the car. The force F1 of the driver's foot on the brake pedal moves piston X. The space between piston X and Y is filled with oil which cannot be compressed. This point is important. The force F2 exerted by the oil moves piston Y. This force is applied to the brake mechanism and the wheels of the car. The area of cross-section of piston X is 4.8 centimeters square. The force F1 is 19 Newton. Calculate the pressure exerted on the oil by piston X. Okay, how to find out the pressure on the piston X? We already know the force F1 is 19 Newton, and we know that the area is 4.8 centimeters square. And we know how to find out the pressure on the solids, on the piston. Pressure is equal to force over area, which is force is equal to 90 over 4.8. So the answer is equal to 1.4. Sorry, the answer is equal to 18.75. Now we have to, this is the answer, but we should write the unit of the pressure. We already used the force. The unit of force is Newton in this question, and the unit of which given us in the question is centimeter square. So the unit is 18.75 Newton per centimeter square. Let's continue. The pressure on piston Y is the same as the pressure applied by piston X. Explain why the force F2 is greater than force F1. Okay, when we look at the question, when we look at the pistons, the pressure 1 is equal to pressure 2. So when the pressure 1 is equal to pressure 2, pressure 1 is equal to pressure 2, the pressure on the piston 1, F1 over area 1, and the pressure on 2, F2 over area 2. And when we look at the areas, A2 is greater than A1, so that F1 or F2 must greater than F1, otherwise cannot be equal. Piston Y moves a smaller distance than piston X. Why the piston Y moves a smaller distance than piston X? Because of the work done, the piston 1, the work done by piston 1, the piston X, is equal to the work done piston Y. So, if the work done are equal, the work done X is equal to work done Y. So, the F1 times distance, D1, is equal to F2 times distance 2. If F2 is greater than F1, the distance 2 must smaller than D1, otherwise cannot be equal. Suggest why the braking system does not work properly if the oil contains bubbles of air. We know that the air is compressible. Air is compressible. If if the oil contains bubbles of air, so that when air bubbles compress when pressure applied, systems becomes less efficient, or the pressure will reduce by applying the pistons. 1. Air bubbles compress when pressure applied. So system will be less efficient or pressure reduced. So what we want exactly, what we want in this question, in this hydraulic braking systems, the piston X, when we apply pressure to the piston X, we want to get the same pressure on piston Y. We don't want a bigger or smaller one. You want equal pressure on both of that. So the liquid is transmitted the pressure equally to the piston F2. But if this oil contains air bubbles, couldn't do it. Let's look at the question 2. Define pressure. When we define a pressure, pressure is equal to force over unit area. Pressure is equal to force over unit area. A closed box contains a gas. Explain in terms of molecules how the gas exerts a pressure on the walls of the gas. When we have a closed box like this one, I can say, and if there's air inside this box, the particles move freely, and so they will collide with the wall and each other, and so that the molecules exerts force on the wall. Molecules collide with surface of box. The molecules exerted force, molecules exert force on the wall. And so pressure is equal to total force divided by total area of wall, and it gives us the total pressure. The figure 6.1 shows a flask connected to a pump and also to a manometer containing mercury. The right-hand tube of the manometer is open to the atmosphere. The pump has been operated so that the mercury levels differ. We remember that the manometers and give us the pressure differences. In this part, when we remove the air from the flask, the atmospheric pressure pushed the mercury to this side. As shown by 250 millimeter, the density of mercury is 13,600 kilogram per meter cube. Calculate the pressure in Pascal due to 250 millimeter column of mercury. We need only this part. This is the height of mercury. How many pascals? pressure is equal to height times density times gravity. What is the height of here? The mercury, the height of mercury is 250 millimeter. But we should look at the mercury, the density of mercury is meter cube. So we have to convert the 250 millimeter to the meter, which is 0. Divided by 1000, 0.25 meter. 0.25 meter times, the density is already 13,600 times 10. And the answer is equal to 34,000 Pascal. The 250 millimeter of mercury is, the pressure in Pascal is 34,000 Pascal. The pressure of the atmosphere is 1.02 times 10 to the power 5 Pascal. Calculate the pressure of the air in the flask. In this point, we should look at the manometer. The atmospheric pressure is affected from here, and we need the pressure air in the flask. And we know that the atmospheric pressure is greater than pressure air. How to understand that? Because the mercury is going this level, so that the pressure atmosphere is equal to pressure gas or air plus pressure height of mercury. So the atmospheric pressure is 1.02 times 10 to the power 5 Pascal. The pressure gas we don't know. We already know the height pressure is 34,000, which means 0.34 times 10 to the power 5 Pascal. So the answer, pressure gas is equal to 1.02 times 10 to the power 5 minus 0.34 times 10 to the power 5, which is equal to 68,000 Pascal, or 6.8 times 10 to the power 4 Pascal in scientific notation. Let's look at the question 3. If you see the questions, those type of questions are repeating. So we must know that to describe the motion of the molecules of the gas into a cylinder. Figure 6.1 shows the quantity of gas in a cylinder fitted with a position P. Describe the motion of the molecules of the gas. And the question is 3 marks. We should find to give out the 3 steps of the behavior of the molecules. So the first things we can say, molecules move in random directions, and molecules move very fast. Molecules move very fast. At high temperature, and molecules collide each other and with walls. That's it. The piston is now slowly pushed down to decrease the volume of the gas. The temperature of the gas does no change. Well, remember the Boyle's law of pressure times volume is always constant when temperature is constant. So when we reduce the volume, increase the pressure. How does the pressure increases? The pressure increases with more frequent collisions. The pressure increases with more frequent collisions, but we should know that the PV is always constant. So when the volume is decreases, the pressure is always increases. Why the pressure increases? Because of the more frequent collisions. State and explain in terms of molecules what happens to the pressure of the gas. Actually, we already explained that in this part. The pressure times volume is constant because of Boyle's law. So the pressure increases with more frequent collisions. Before pushing the piston down, the pressure of the gas was 1.0 times 10 to the power 5 Pascal. Pushing the piston down reduces the volume of the gas from 500 to 240 centimeter cube. Calculate the final pressure of the gas. What we know that before pushing the pistons, the initial pressure is 1 times 10 to the power 5 Pascal. And we don't know the final pressure. What is the initial volume? Is 500 centimeter cube, and the final volume is 240 centimeter cube. So we already discussed in the first question, P times V is constant. So the initial pressure times volume initial is equal to pressure final times final volume. If you put the values under the formula, we don't need to exchange the units because of they have the same units and they cancel each other. So the pressure final is equal to 2.1 times 10 to the power 5 Pascal. The question 4, a large stone block is to be part of a harbor wall. The block is supported beneath the surface of the sea by a cable from a crane. The figure 2.1 shows the block with its top face at distance height beneath the surface of the sea. The force acting downwards on the top face of the block due to atmosphere and the depth of height of water is 3.5 times 10 to the power 4 Newton. The top face of the block has an area 0.25 meters square. Calculate the pressure on the top face of the block. We know the area and we want the pressure on the top of face of the block. So the pressure is equal to force over area. We already know the total pressure from the atmosphere and the height of depth liquid. The force is 3.5 times 10 to the power 4 Newton over 0.25. So the answer is equal to 1.4 times 10 to the power 5 Pascal. The atmospheric pressure is 1 times 10 to the power 5 Pascal. Calculate the pressure on the top face of the block due to depth, height of water. Now, when we look at the question, the total force due to depth of height of water and atmosphere. And so we already know the atmosphere, and so we have to find out the depth, height of water. So what is the total pressure? 1.4 times total pressure, 1.4 times 10 to the power 5 Pascal. If you do this, total pressure is equal to atmospheric pressure plus pressure height. So 1.4 times 10 to the power 5 is equal to 1.0 times 10 to the power 5 plus pressure height. So the pressure height is equal to 0.4 times 10 to the power 5 Pascal. This is the depth, height of water. The density of seawater is 1020 kilogram per meter cube. Calculate the depth, height. So the pressure is equal to height times density times gravity. If you find out the height is equal to pressure over density times gravity. So 0.4 times 10 to the power 5, we already calculated in the previous one, and 1020 times 10, which is equal to 3.9 meter. 3.9 meter. Suggest 2 reasons why the tension of force in the cable is not 3.5 times 10 to the power 4 Newton. The tension is not equal to 3.5 times 10 to the power 4 Newton because of the weight of the block, and secondly, the upward force of water. The block is lowered so that it rests on the seabed. State what happens to the tension force in the cable. Of course, when the block is rest on the seabed, means the tension force becomes smaller or equals to the 0. Tension force becomes smaller or even 0. But the tension force, it will reduces. The question 5, the figure 3.1 shows an oil tank that has a rectangular base of dimensions 2.4 meter by 1.5 meter. And also you know that the depth of the oil, 1.5 meter. The tank is filled with oil of density 850 kilogram per meter cube to a depth of 1.5 meter. Calculate the pressure exerted by the oil on the base of tanks. Calculate the pressure exerted by the oil on the base of the tank. So in this question, we already know the density, we know the height, so pressure is equal to height times density times gravity. What is the height? 1.5 meter times 850 times 10. So the answer is equal to 850 times 1.5 times 10. That is equal to 12750 Pascal. The force exerted by the oil on the base of tanks, force is equal to pressure times area. So the base area, we should find out the area of base, which is 2.4 times 1.5. Pressure is equal to 127 times 50. Sorry, I made a mistake. Times the base area, 2.4 times 1.5. This which is equal to 12750 times 2.4 times 1.5, and that is equal to 45,900 Newton. The force calculated in A2 is the weight of the oil. Calculate the mass of oil in tank. The weight is equal to mass times gravity. You can remember, wow, my goodness. 45,900 is equal to mass times 10. So mass is equal to 4590 kilogram. When he's checking the level of oil in the tank, a man drops a brass key into the oil and it sinks to the bottom of the oil. State what this shows about the density of brass. The density of brass is greater than density of oil. Explain how attaching the key to a piece of wood could prevent the key from sinking. When we attach the key to a piece of wood, it will prevent from sinking because of the wood is less denser than oil, so that it can remain without sinking. Thank you very much, guys, for listening us. This is my channel, Yasin Şöhret. You can follow me on this YouTube channel. Thank you very much.